So my name's Pierre. I'm a site reliability engineering manager at Populo. We're a small company, medium company based in Cork. We do software for internal communications to help medium to large companies to engage better with their workforce. And our engineering department is about 50 people, and my team in SRE, we're actually 3 people. And that means our SRE model is essentially helping others and helping teams manage their applications in production. We don't do it for them, we don't operate them, but we give them the tools and we give them the practices so that they can do that themselves, because they're the best. There's the best people indicated for doing this. So my background originally is as a software developer. For years I've been a software developer before moving to the kind of DevOps reliability side of things. And for a long time, at the start of my career, I kind of had things backwards. For me, production was that kind of magical land where things went to actually go to customers when I was finished and I was committing my changes. Then I was moving on to the next story or to the next feature. And somebody else was operating it. It might have been released only a few months afterwards. It wasn't really on my mind. And as things progressed along, maybe I would have been working with some people in ops, getting some logs when something was going wrong, all these kind of things. But overall, all the progression that we had made even in the last few years, it was still focusing for everything that was happening before we reached production. It was, can we do better testing? Can we do better validation? So practices now are really well adopted. TDD, integration testing, end-to-end testing, staging environments, all of that work, it's still only happening before that kind of endpoint where we say, well, now it just goes into the real world. So I think we're getting to a point now where things are changing. We have to see production not as the end goal. This is actually the starting point. This is when now things are getting real. And it's actually understanding and be ready to understand that our systems, whatever we try to do to test it, to validate it, to foolproof it, they're never going to be immune to failure. There's always going to be something that's going to make it through the cracks. And if we keep spending that time testing and not actually worrying about what happens after production, then we're actually fooling ourselves to that false sense of confidence that, well, we can actually build the perfect thing. And I've listened to an interview of Charity Majors, who's going to be on the track this afternoon, and she said something that struck me that was really, really true for these kind of situations, is that if we fool ourselves into believing that we can build the perfect thing and that we can be immune to failure, then when that failure happens, first of all, we're not ready for it, and it's going to be failing really, really hard, because we can build very strong resilience, but then for that one case we didn't think about, this is just going to be much worse. So let's be ready, let's be prepared and be comfortable with failure, because this is going to happen. So all these things are kind of valid for any kind of systems, right? But when we're talking about distributed system, then this is just exponentially worse, because now we have decoupled some kind of standard monolith. Now this is like a lot of distributed applications. This is automatically scaling. This is now talking over the network. The network is obviously going to be unreliable. So there's a number of moving parts now. And this is just so many more places when things actually can go wrong. So we have to adopt that mindset and saying, well, first of all, now I don't know. Like before we didn't know how things could go wrong. Now we just have a lot more places. So isn't that just monitoring, though? And like, if you're here, you probably like heard some discussions and a lot of kind of debate online about what's observability. Isn't just that monitoring. And there's one core difference here, is that monitoring is based on getting alerts. It's based on getting notified when something is out of the normality. And that concept of normality is just really ingrained in the fact that we know about it. We know a threshold. We know what normal looks like. But what about everything else? What about all the things we never thought about? What about that weird scenario that when it's going to happen, that we maybe we'll get an alert for something else, but then when we start to try and dig it in, then that's not going to be something that we can do with just monitoring. And that's where observability comes in. And one quote that sums it pretty well is from Baron Schwartz, who's like one of the big actors in this world of observability, is that they're kind of complementary. So monitoring will actually tell you if your system is working. It's that normality. But then observability is coming hand in hand with it, saying, well, when it's not working, now can I have the tools to ask the right questions? Can I start investigating problems? Can I adopt the scientific method of formulating a hypothesis, asking questions, and then proving or disproving proving those theories? So this is the reasons why we want to know better on the stuff that we're running in production. So there's, so Sarah mentioned the pillars of observability. So most of the pillars, most of the time, is 3 pillars. I think health checks don't tend to be there in most of the literature, but so metrics, logging, tracing, they're the common ones. I really like to include health checks in this because this is kind of a high-level visibility tool that is the kind of table stakes of, well, can you actually see kind of a green, red light scenario. So what I'm going to be doing for the best part of the talk now is going through all these techniques and what they're good for, what they're not good for, what to look out for, and essentially how they complement each other to create a better picture of having that visibility in production. So kind of level 0, really, health checks. Health checks are a traffic light system. Basically, even red light, green light. What do I have running? Is it running? And it's answering a number of questions. And your mileage may vary on the type of stuff that you want to instrument for health checks. The main question is it running? I have a server. Is it up? Is it down? But we can add more information into those kind of health checks. So it's up, it's running, but maybe it's not actually able to do what it's supposed to do, maybe because some of the dependencies are not available or it doesn't have enough resources. And if it can't perform its task, maybe is it saturated? Can it do a few more things, or do we need to spin more instances? And overall, like these questions are pretty generic, and they may vary. You may want to ask slightly different questions depending on the type of service. But the main thing is that there's a high-level thing that gives us a clear view when we're managing an incident, for example, saying, actually, what's there? What's healthy? Just kind of a big screen of saying, hey, this is red, this is green, and let's go look at what's going on here. And the first thing is, so like the kind of techniques that you can adopt for instrumenting services or applications for health checks is like that can be a simple broadcast. So just all that information, just put it into a packet and just broadcast this on the network. And what it will give you is, well, all of the information for whoever is interested to listen to this. Like, this is kind of basic, just very basic stuff. If we want to graduate a little bit from that, is instead of broadcasting it, we can use some kind of HA store like Zookeeper or etcd, and all that information, put it in a registry, and the typical way that thing would work is that whatever we put in the registry comes with some form of TTL, so that if the service doesn't keep registering it, then it's considered down. But we can also flip that picture and saying, well, rather than the service or the application being responsible for advertising all of these things, is, well, maybe just make it available. And that's kind of the typical way now it's done. And if you're using systems like Kubernetes, this is the way health checks are typically done, is an HTTP endpoint /health that will return 200 or 500, depending on the health, along with a body with some interesting information for debugging purposes. So what it might look like is something like this, right? So that /health endpoint that may need to be discovered one way or another. And if you're using an orchestration system, then that you can discover those things pretty easily. And that can get polled to just basically get all that information. And the important thing here is healthy is true, but there's a lot more information in here. Like, we know now what services, if there's a workload, what are the dependencies, what is the status of the dependencies, and now we have a much bigger picture of actually the status of that kind of service. Now, all I said so far now was to gain that visibility, but health checks are most of the times used for other things, such as resiliency and operating and kind of automating things around our services. And that's where we need to be very careful about what we mean about a service being healthy, because otherwise we get into situations like these. And I'll give you an example. When we started doing this, probably like about 3 years ago, we're pretty overzealous with our health checks, and we had a service that was depending on Kafka and on Zookeeper, and we said, well, our service shouldn't be considered healthy if Zookeeper isn't healthy, or if we don't have the right number of brokers for our Kafka cluster. And what happened then is we actually deployed that service, and what we saw is it just kept restarting all the time. It just kept getting killed all the time. And the reason for this is that our health checks were, first of all, they were too expensive, because every time we were hitting the /health endpoint, what it was doing is go and try to connect to Kafka, and that can take a little bit of time. But then the next thing is, when we were doing that, we were also almost DDoSing our infrastructure, because we were just kind of constantly asking and creating connections with Zookeeper. And even relaxing that, even caching these kind of information, then it actually just came back and asking the question is that, well, if Zookeeper came down, should we really actually consider that our service is down? Because now if everybody does this, if our dependency upstream is actually saying the same thing, well, it depends on your service, if you're down, I should be down, then we get into situations like kind of cascading failures where we just took down our own infrastructure just because we tried to make it resilient. So something to be careful of. So this diagram and that kind of approach comes from a blog. Definitely, like those slides will be shared. So definitely take a look at this. Okay, so now let's get into the meaty stuff. So metrics, that's one of the big pillars of observability. And if you're familiar with metrics, you're probably familiar with the different levels at which we have those metrics. So typically something that we've been very good at for a long time is system metrics. So at the node level, CPU usage, memory, disk space, all of these things. They're like system administrators have been very, very good at this stuff for a long time. But then when it comes to application levels, this is something that we've only started really doing recently. So error rates on APIs and general application level metrics. And then further up, there's all those business metrics. So now it's customer impacting level stuff. It's now, do I get customer conversions? Do I get stuff put in a basket? Are people buying the item that I'm selling on my e-commerce website? And these three types of metrics need to work in tandem. If we have a team of, the infrastructure team that's actually managing the systems that are using their one system, and then suddenly the product teams are saying, well, we'll really like Prometheus, we're going to put that in place as well. And then at another stage, we're using Google Analytics for our third part. And then suddenly, we still have this disjointed view of, well, all of these things should be correlated together, because when we're going to be managing an incident, we should be looking at all of these things through. Maybe our sales are going down in the last hour because we're getting more 500 errors in that particular service because the network latency increased between our data centers. Something like this. All of these things, even though different teams may be more interested in some chunks, we have to be able to make that relation between all these things. And when we get into the cloud native space, this is becoming even more complicated because we have all these things now. And it's all that infrastructure, this is dynamic. We're running in the cloud, we're auto-scaling, we have clustered databases over multiple data centers, but over different regions. We have services that have loads of different instances, or all of these instances are kind of churning through a lot of short-lived cycles. We release often, we scale often, we might have dynamic scaling. And it's no longer the case that now we can have like one place say, well, I want metrics, I'm just going to look at an SSH into this server. That doesn't happen anymore. So what we need is some structure where we have a way to expose metrics in a common way, ship them properly to a collector, and store them in a place that we're going to be able to query reliably without having to worry about all that complexity of the general structure, our general architecture, and the way we're actually deploying our services. And then from then on, we have that view where we can distill all of that information. We can query it for debugging purposes, or we can query it for monitoring purposes, creating dashboards, triggering alerts. And so that's the general, kind of the main kind of picture that it would look like for collecting metrics. For us at Popular, we're relying heavily on Prometheus. So what it looks like if you're using Prometheus is like a very, very close picture. Prometheus is very, very powerful in a way that it has a lot of service discovery, and it has very powerful time series database, simple query language to use. And it works in a similar way that the health check that we just talked about. An endpoint on a server, that's running on, like on the daemon on the server, or an endpoint on our given instance of our service. All of these things that are discovered dynamically, and every of these endpoints is exposing their current metric at that current state. And Prometheus will just constantly just go, what's your metrics, what's your metrics, what's your metrics, store them in a time series database, and then we can query it. And then we can plug that into systems like Grafana to create nice and pretty dashboards. Dashboards are not always useful, but they're usually a good place to start. And then we can use that to create rules, because once we have all of these metrics, once we have all of that information, we can understand now what normal looks like, create a threshold, and send alerts. But there's more to metrics, though. There's more than metrics to increase that visibility. And relying on metrics and thinking that metrics is the only thing is the danger. Prometheus is very powerful, but it's not very powerful for everything. So first of all, metrics is not just about monitoring. Metrics are not just about sending alerts. Not every metric deserves an alert. And if you don't have an alert for a metric, it doesn't mean that that metric is not useful. That metrics might come very handy when you come to an incident that you want to create some queries. You may not, like, I guess memory usage. Are you going to be alerting on memory usage? Probably not. But when you're investigating what's going on, that's a very interesting number to look at. So the alerting typically is limited to the user impacting symptoms. Now, is anybody using Prometheus here, yeah, in production, yeah? Anybody tried to put some very high cardinality stuff like user IDs or email addresses in there? Well, not many people, so the people who didn't raise your hand, don't try, because that doesn't work. And even though Prometheus 2 came a long way, I will say that this is a very tricky thing to say. When it's almost in a situation where, you know, when all you have is a hammer, you just try to use Prometheus for everything. And which means that when we can't use high cardinality, what I mean by high cardinality is to have metrics that we can decompose on a very, very small granularity. So essentially looking at the error rate for a given customer. So you might have 100,000 customers. You actually want to see the error rate of a specific customer. And that's very important for debugging purposes, but time series databases are typically not built to handle that amount of time series. So for debugging purposes, this is no good. And the amount of data we're going to be actually putting in those time series databases, we are doing it because we want real-time querying. We want to be able to have a number of rules that are evaluated very, very fast, because this is how we get our alerts. But then there's some trade-offs, because we can't keep all that data forever. Otherwise, those queries are going to be very expensive. So that means for long-term analysis of maybe business metrics from a real business point of view, like things that you may do with Google Analytics, you won't be able to say, actually, last year, like, what was this customer buying? It's like, this is, if we're trying to do this with metrics, typically, we're going to get into a bad place where it's just like the worst world for everybody. So how do we do high cardinality then? Well, there's one thing we've been kind of doing forever is logging, right? So logging has been around since any program was written, and when we're distributing our systems, then this is just way more complicated, because now there's just a lot more logs, and we have to make sense of them. So the first thing is, obviously, they have to be aggregated, they have to be centralized in some way. But the bad news is just aggregated logs, if you can understand them, this is just a lot more logs in just only one place, right? So if you can't search them, and I think yesterday somebody mentioned that, that quote of saying that, like, we turned our monolith into microservices so that every outage could turn into a murder mystery, right? So if you have millions of logs into one place, that murder mystery is just going to be a very, very long game of Cluedo, because, and I don't know if you've ever played Cluedo as a kid, but typically, I'm sure you've ever been in that situation where nobody puts 3 cards in the middle thing, and then the game goes on forever. That's what it looks like if your logs are just all over the place. So we need to be able to search them, right? So that means some kind of common format, some kind of basically commonality between those things. And then the next thing, once they're searchable, is we need to have them correlated. And the correlation is to be able to trace our requests throughout the system. And what it looks like is, for an example of a basic kind of distributed system, a few services, that are connected to a few databases, and our user is getting an error, and we may have some kind of exception tracker or exception notification tracker that gives us basically a notification saying, we have an exception, here's the request ID or the trace ID, and now we can actually see, hey, now from service A we got this error saying, well, we failed to process the order. And as you can see here, inside that message, we have that trace or that request ID that is going to be following everything that we do throughout our system. And that's what that's going to allow us to do is filter out the noise of maybe only a few log messages within a million. So by looking at this throughout our logs, so in our log aggregation system or in our log querying system, we can just look at only the ones that are interesting us and then track down everything that happened through. And then throughout all that noise, now we're able to see where the problem happened, pinpoint exactly where the exception was or the issue was happening. And one thing that's interesting here, and that I didn't add here, is timestamps. And because timestamps in logs can be very treacherous, because what's the timestamp in a log? Is it when the event happened? Is it when the message was actually logged on disk? Is it when the log aggregation system picked it up? And are we sure that all those clocks are lined up? If all these things are happening very quickly, is it going to be in and out of order? Here, there's no doubt. And we don't even need to look at timestamps anymore. So correlation is great. We can see some of that information, but we're kind of still lacking a little bit of context in that in those logs, right? So I'm sure maybe have you ever seen a log entry like this? Does it look familiar? Yeah. So yeah, if we aggregate a lot of them, that's just not much better. So if we're going to be relying on our logs for debugging our systems, how can we actually be more helpful? How can we provide more context? Logs are cheap. This is just text. So first of all, what do we have in here? So we have a timestamp, which we may or may not want to be relying on. What's the message? So we have an error that says read timeout. OK, it's probably something that had a request that didn't actually complete in time, or some service was gone before the request was completed. But could we actually just be more helpful, right? First of all, what is it? Like, what is the error coming from? So maybe we can say that's the registration service. That's like one instance of our microservice. It's maintained by the team that deals with events. So all that bounded context of events might actually be, so we can see actually that error. We know I'm operating that system. I'm seeing this error. I know what team to talk to. What is it even running? What's the service in here? Can we have the commit number? Can we have the build that actually generated that? Can we even have the runtime saying, actually, I know exactly the minor version of Java that's actually generated that error? And we can keep going on. Where is it? Like, what region? Like, what node is it running on? If I actually wanted to see, how come that particular node has this instance, and now this is behaving differently than another node? Why is it? And then we get to the high cardinality stuff. Who did cause that error? Who did that happen to? What's the customer? What's the user? And obviously, we have to be a bit careful here. You know about GDPR. Probably don't put email addresses in there, and don't output things that are going to be coming to bite you. But we can keep going on, and then tracing it if we want to get a request ID, and then just plug that into our tracer, or plug that into to be able to request all the logs that have the same request ID. And any other information that's valuable in that context. That error might have happened in some particular specific place of your system. Maybe there's other stuff that's valuable when you want to debug. And what do we do with all of this? Well, we just bunch it up in a JSON, and then we ship that instead of shipping the thing at the top. And that's structured logging. That's adding a lot more information, a lot more context. And what it does now is it unleashes a lot more debugging power to your log trace. Like, logs are just massively underused, and I can guarantee you in the next while, in the next few months or in the next year, logs, structured logs, events, that's going to get a lot more love because there's just a lot of power in there. And you can see it because there's a lot of companies that are now picking up on this. So what does that mean, exploring high cardinality? It means that if you ship that kind of stuff inside Kibana, so that's an example of something that I got from our Kibana, where we're shipping those sorts of logs. And you can see here there's that kind of spike, and if we investigate it further, we can see actually it looks like there was nothing happening for a specific customer, and we see that actually at a particular time, we can isolate it. If that cardinality, if that information about the customer wasn't available, we would not have been able to isolate and create that graph at the bottom saying, actually, up until 5 o'clock, nothing happened. And why is that? If that graph at the top was just kind of one color, there's an activity spike, but you don't really know much more than that. And as I was saying, there's other companies doing that stuff more in depth, and they're specializing in this. And so Charity will be on stage this afternoon again, and probably talking a little bit about Honeycomb. But that's taken off their demos, and it shows that here we can isolate an error rate that happened during a canary build, saying, actually, now I have my build number, and I can actually see this is what happens when I see an error rate, and I can say, well, can you just show me the error rate depending on the build version? So I mentioned traces a little bit, and the reason I'm mentioning this is because structured logging and tracing have a good bit of commonality. And if you've been to the talk yesterday on the microservices track by Edith, she mentioned open tracing with Jaeger. So what we're using in Populo is open tracing as well, but through Zipkin, which works very similarly. And the way tracing works is it just takes all that information and just shows you that information over a timeline. And that request ID, and one of the things we're using Zipkin for in our teams is, instead of generating request IDs and regenerating trace IDs, we just use Zipkin for that. So anything that enters the system gets a trace assigned, and this is what's going to be correlating everything. So when we get that error and we have that trace, well, yes, we can go to Kibana and say, give me all the logs that are related to this, but we can also go to Zipkin and say, actually, just show me the trace. And the trace gives us that picture, that isolated picture over time of what happened. And it can tell us a lot of things here. We can see that main request took 172 milliseconds because it spun two requests to other services. And inside here, we have a bit even more of kind of white box tracing, where that service is even instrumenting more of its work through tracing. And we can know that, OK, one service spent a bit of time in Cassandra, the other one took a bit of time in MySQL. So overall, that big thing overall is the trace, and that's composed in multiple spans. And what it looks like in Zipkin is things like this. So that's just taken off the Zipkin website. But I can say for when we started using Zipkin, probably a year ago, even within the first half day, we found 2 or 3 things that we had no clue were happening. It's very interesting to see some of these things on a timeline like this. And it's funny, like a few months ago, we were trying to build a new feature, and one of the team leads came to me saying, like, I don't think that's going to work, because can we look at this trace here? Basically, there was for a given request, it was spanning out like about 500 other requests for other services, and it was just kind of exploding inside our system. And it's the kind of thing you just go, oh yeah, well, that's kind of stupid, like you should have known that. But the reality is, most of the situations where you're going to be debugging something, it just looks stupid when you get to the end and you figure out why. For the whole journey, it just looked like some really, really eerie situation. Other situations where we've used this is to really pinpoint specific issues. So one case was that we were suspecting some DNS resolution problem between services. And obviously, like I suppose talking to our ops side, we're like, no, not a chance it's DNS. DNS is not a problem. And yeah, DNS was the problem, as it usually is. And interestingly, we actually were able to provide them with a trace saying, yeah, this is taking 10 seconds on DNS resolution. That's just wrong. But I will say the downside of this is we had to instrument a lot more for that specific problem. And that's, to me, that's where the downside of tracing comes in, is you still have to know a little bit what you're looking for. So you're almost in a way that you see the problem happening once and just go, well, I would like to ask a question, but I don't have the information, so I'm going to have to instrument it and wait until it happens another time. And that's, to me, the little bit of the challenge of tracing, and this is probably why the adoption of it overall is a little bit slower than other things. I would say one other difficulty is if you already have a system that's already set up, it's pretty expensive to retrofit tracing into all the services. And unfortunately, if it's not retrofitted everywhere, then you kind of have black holes, because you have the tracing and then the trace stops, and then maybe you have another trace that starts later, but there's no way to correlate them with each other because they started separately. And I'll say, like, so we started that about a year ago, and we still haven't got to the point of actually implementing everything, like implementing that tracing everywhere. So if I have a word of advice, if you're starting now, you don't have too much legacy, just put it up front, because it's very cheap. It's actually very cheap to add straight away. It's just a pain to just go back. And systems like service meshes, like Istio, make that a little bit easier, but you still have to propagate. You still have to detect the trace. You still have to push it back. So very valuable, very interesting, and most of the stuff that comes out of it is gold, but there's a bit of a cost to it. So I've talked about all of these different techniques, right? So like health checks, metrics for alerts, metrics for debugging, logging, structured logging, tracing, and like there's not one right tool for the job, right? And that's my point today, is you can't just go and say, oh, I'm going to put Prometheus in here, job done, now we can actually understand our systems. No, because monitoring and metrics, like they're not a substitute for understanding the way your system works overall. And we have that spectrum of, basically on the left side, all the known unknowns. So it's the things we can reason about is the things we know can fail, but that we don't have control on. So things like, health checks, they live kind of on that side. So we have that kind of understanding of, well, I know if this is working or not. We have metrics for alerting. We understand what normal looks like. We can create alerts. But again, that understanding of what normal looks like is very much under the known unknowns. We might know that like our request rate or our response, the latency should be of a given time, but we don't really have a control over it. So at that point, it suits very well. It suits itself very well to kind of service level monitoring. But metrics are better than just monitoring. Metrics are there for querying. They're there for investigation. And there, we're just shifting now to that right-hand side of, now it's the unknown unknowns. Is when something happens, can we ask questions? Can we go and look at what's happening? And then the further we go, the more debugging power we get for those unknown cases. So tracing, logs, events, structured logging, more context, because we now want to explore more. And so on that left-hand side, we're in a kind of known world of monitoring resiliency. So health checks, as I said, they can not only just be used for understanding how things are up or down, they can be used for orchestration systems to say, if something is unhealthy, I'm going to restart it. If I have a health check telling me it's not ready, I'm going to wait until it's ready until I ship something to it. And same thing, the metrics. It's automated. It's just going to be running rules for specific things that we want to find out. It's going to send us alerts. It's going to send us notifications. And we can react based on that. But most of that is mostly automated. This is all machines. That other side is people. And that's just us on incidents, responding to on-call, responding to a problem. And this is where we have to be very, very powerful, because this is now, we're diving into the unknown. We have to have instincts of saying, I'm going to look at this. I might start on a dashboard, but I need to have the power to query something else. I need to be able to look at things for a specific customer, for a specific build, for a specific machine, for a specific region. And we can't decide up front what we're going to be needing, so provide as much context, as much information. And since it's humans on that side, the usability of it is just paramount, because all of that stuff, if it's just unusable, if it's really hard to instrument, it's just going to be all for nothing. It's interesting. We ran a survey internally from our SRE team to our entire engineering department to understand how they were using the different tools that they were at their disposal for monitoring and metrics and all these things. And interestingly enough, Zipkin is quite powerful, but most people didn't know about it or didn't know how to use it. And for us, we were really quite happy with Kibana, but everybody hated it because it was just hard to use. Everybody was pretty cynical about using it. And we tracked that back down to a lack of trust of what was in there. Because historically, we had issues we're in a certain situation where we have to manage our own Elasticsearch clusters, and for anybody that is doing this is very hard. And that trust is really, really required for everybody to start using it, because otherwise, everybody's just going to go back to, say, SSHing to machine or looking at logs of a specific thing. So overall, throughout that journey, it needs to be very simple or even as possible, just even no touch. If we can have a situation where we say, well, I'm giving you kind of the bare skeleton of a service that now is already instrumented. Things that I mentioned before about commit numbers or service or teams or these kind of things that are putting into logs. It doesn't mean that the developer has to log them. If you're using, for us, we're doing this through Kubernetes in FluentD. You can have logs automatically picking up more labels and more information as they get out. It's this is totally invisible, but it's just so much power that's come for actually free for the teams. So there is effort required in all of these points. We can't just say, here you go, now you have Prometheus, now you should know how to debug your systems. No, there's a bit of education there. And we're all doing that because we want to know better. And that's all coming to the assumption that we actually want to know these things. If we get into situations where knowing these things is going to come back to haunt you or come back to blame you, then again, everything is just done for nothing. Because if we don't have the trust that all of the people in the company or that general culture will not go back to say, actually, now I found out who the responsible person was for that outage. It's not about that. And that trust is a trust for teams. So first of all, as a team, we trust that we know our system better. We know the way our system works. But it's a trust for the people who operate our software as well. They might not be the same people who build it. You never know. It's that trust for these people that they'll actually be able to gather the right information when there's a problem. And it's that trust for even the general company that as engineers, we actually know what the hell we're doing. And I'll give you an example of what we've done. At Apaplo, we have a very, very good support team. We have frontline support that we're really proud of. And what we've done after a while is we said, well, all of these metrics, all of that visibility that we have, how can it be useful to them? And obviously, we don't want to give them very complicated dashboards about latency and about our traces or these complex stuff. But even distilling that information to something that's worth to them. When they get a call from a customer, can they actually see? Can they have a place to go and see? Is the system generally slow, or do we have a backlog of a certain task in a batch or something like that? And they can understand this and first of all give a quicker answer without a handoff to ask engineering. But they can also get ahead of problems because now they can actually see, oh, yeah, this big customer that's about to do this kind of big project, but we're in a situation today where this morning, if they do it, they might actually just get into some trouble. All of that stuff, it's just worth more than just what we do as part of product teams. And one of the things that I find very interesting in that space is, as engineers, we always work, we're not short on work, right? It's when we work on something, it's because we don't work on something else. And then this is outside of the debugging case, but on our instincts of saying, I want to change something, I want to refactor that code. I don't really like this piece of code, I think it doesn't perform well. And I'm pretty sure you've been in those situations where there's those kind of endless, meaningless, aimless refactoring that happen just for vanity purposes. And I've done that. It's oh, that doesn't look so pretty, I'm just going to rewrite it. But if I'm doing this, I'm not doing something else. So can I actually leverage all that information that I have to investigate, saying, well, I believe this code is wrong because I believe this code is wrong. Can I ask a question about why? Can I have some metrics? Can I have some data to back it up? If I don't, maybe I should instrument it so that there is more data to back it up. And then when I'm done with doing something, then I can actually see if I've done it better. If we have nothing, we're even in the worst situation because we won't know if that even made the system worse. And I mentioned that throughout the entire presentation, but like that visibility, it goes hand in hand with being able to operate a system. So we need to spend time for the people who are going to be on the other end of that production line. Ideally, and like I think this is where we're trying to get at Populo, is we want our teams, and we're really striving for our teams to be operating their systems because they're the best people to do this. But if they don't have the tools to do it, then inevitably they're always going to go back to operations, to infrastructures to do this. So this goes hand in hand to get that progress going. So I'll leave you with just kind of one quick thing is production is just the start. Testing is important, testing is great, but maybe don't spend all your time on it. Keep some for instrumenting your services. Thank you very much.